Hello everyone, welcome back to Think Lab by Saurabh. So today we are going to explore one of the most exciting technology of the next decade, quantum AI, right? So you may have heard the term like artificial intelligence, quantum computing, chat GPT or Google Velo. So but what the exactly the quantum AI? It is the another AI buzzword or it is the next technology revolutions. So let's understand it step by step. So first, let's understand what is the artificial intelligence. So artificial intelligence or AI is the technology that allow computer to perform tasks that normally required human intelligence. For example, AI can recognize the image, understand the language, write the code, generate the video, recommend the different product and answer the question. So today's AI models such as large language model run on a powerful classical computer. So these computers are extremely fast, but they have still some kind of limitation. So now let's understand the quantum computing. So traditional computer use the bits. So what is the bits here? A bit can have only one value at a time. It is either 0 or 1. So every application you use today ultimately run using the billions of these bits. So quantum computer work in a very different way. So instead of bits, they use qubits. So what is the qubits? So a qubits can represent 0, 1 or combination of both at the same time. So this unique behavior gives the quantum computer to perform the very fast computational power, right? So what is the quantum AI? So quantum AI is the combination of artificial intelligence with quantum computing. So in simple word, AI provide the intelligence, right? And the quantum computing provide a new way of computations. So together they can solve some problem much faster than the classical computer. So quantum AI doesn't replace AI. So instead of enhancing AI by giving its access to more powerful computation for suitable problem. So now let's compare the classical AI and quantum AI. So classical AI run on the CPU and GPU. Quantum AI run on the quantum processor. Classical AI use the bits. Quantum AI use the qubits. So classical AI process the information step by step. Quantum AI can explore many possible solutions simultaneously for a certain algorithm. So classical AI is already widely used today. Quantum AI is still in the research and early commercial stage. So quantum AI is not replacing today AI overnight. Instead of they are expected to work alongside of classical AI. To understand the quantum AI, we need to learn this three important concept of quantum. The first concept is called superposition. So imagine a normal light switch, right? So it can be either on or off, right? Or there is two state, either on or off, right? Either we can say 0 or 1. So that is the similar to classical bit. So now imagine a special switch that can represent both on and off until you measure it. So that is a similar to the qubits. So this allow quantum computer to represent the multiple possibility during the computation. The second step is the second concept is called entanglement, right? So we call entanglement, right? So this entangle, what is the entanglement? So two qubits can become very strongly connected, right? So even if they are separated, their states remain correlated within the quantum system. So this allow quantum algorithm to coordinate information in particular way that the classical system can't easily replicate, right? So entanglement is the one of the key resource behind the quantum computing, right? That is a very important concept is the entanglement. So now the third concept is called the quantum parallelism, right? So what is the quantum parallelism? So a classical computer often check the possibilities one after another. Some quantum algorithms can process many computational paths simultaneously. So this makes quantum computer especially useful for certain optimization and simulation problem. It is important to remember that this does not means every program become instant fast, right? So quantum speed up apply only to a specific class of problem. So now let's look the real world applications. So in particular healthcare, quantum AI can help researchers to simulate the molecules more accurately. They could accelerate the drugs discovery and the personalized medicine. So in finance also, the quantum computing may improve the optimization, risk analysis, and fraud detection. Logistic, they can perform the deliver the best route, warehouse operations, supply chain planning. So material house, they can discover the new material for battery, semiconductor, and clean energy, right? So in cybersecurity also researchers developing the quantum resistant encryption because the future quantum computer could break the sum of the today's cryptographic algorithms. So let's discuss the advantage, right? So quantum AI has the potential to solve the extremely complex optimization problem. It may improve the scientific simulation. It can also accelerate the sum of the machine learning. It could discover the pattern that are difficult for the classical computing approach. So most important thing is that it's open the possibility of the solving the problem that are currently beyond the practical computational limit, right? So however, quantum AI has also faced major challenges. So quantum computers are very expensive. Qubits are extremely sensitive to noise. They require advanced error correction. Many systems operate at the temperature close to absolutely zero, right? So they are still, there is quite, it's also maintained fault tolerance. Quantum computer is also important. So developing quantum algorithm also required very expertise knowledge, right? So now we try to look at the some popular tools. So IBM offer the Qiskit, Google also offering some framework. So these frameworks allow developer and researcher to experiment with quantum algorithm and quantum machine learning, right? So the major question is, will the quantum AI replace the today's AI? The answer is no, at least not anytime soon. So most AI application will continue running on CPU and GPU. So the future is likely to be hybrid, right? Hybrid AI, combination of traditional AI with this quantum AI. So classical computer will perform most computations. So quantum computer will used only for the problem where they offer the meaningful advantage, right? So if you want to start learning this quantum AI, so first we learn the Python. So because the Python has a strong foundation of artificial intelligence and machine learning, after that understand the linear algebra and the probability, right? Then try to learn the quantum computing and finally practice with the different framework, toolkit framework like Qiskit and other, right? And try to build the a small project. So let's summarize the today discussion. So quantum AI is the combination of artificial intelligence with quantum computing. Classical computer use the qubits. Quantum computer use the classical computer use the bits. Quantum computer use the qubits, right? And the superposition, quantum parallelization. These are the very key concept of quantum AI. And quantum AI has like numerous potential in the healthcare, finance, logistics, cybersecurity, and the scientific research. And also we have to perform the optimization problem. So all the technology is still developing. It could become one of the biggest computing breakthrough in the coming decade, right? So thank you for this watching this video. If you enjoy this explanation, so please like the video, subscribe the Think Lab by Saurabh, and share with anyone interested in the AI and emerging technology. So see you in the next video. Thank you for watching. Happy learning.